about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hi, I am Leandro Facchinetti. Let's write some code together, shall we? What we have on the menu today, hopefully, will be to do multi-channel waveforms. But before we get there, there was something that I was thinking about that I think makes a lot of sense. So check this out. Right now, the way that we are writing our code, at least for auxiliary functions and that sort of thing, is we have an implementation in the library, then we have this test effect that, well, runs some tests for the auxiliary functions. So some things don't have tests, some things we are going to test visually, like the colors and the design system. But things like conversion between different units and some auxiliary mathematical functions, all of those, we have tests here. They are unit tests, so to speak. And there is this principle that I'm trying to adhere to as much as sensible, as much as possible, which is the principle of locality, which says that things that are related should be near in the code base, should be collocated. So I had this idea of how to join the tests with their implementation, because the tests have the purpose of testing for correctness, but they also serve the purpose of documentation. So for the person reading the library, it will be nice to have examples of how to use functions right next to their definitions. So I want to experiment with, this, so to speak, unit testing system. I want to try to change it a little bit so that the tests are collocated with their implementation. So we're going to start by changing the test system, the unit test system. And then we will get to the multi-channel waveform. Maybe. We may not even get there. We'll see. So I think that the way this should work is we should have a function. So on a high level, the way that this is going to work is similar to something, a trick that we played like way back when I was working on the previous version of this library. It's not even here. I didn't open it this time. So in the previous version of the library, we had this notion of initializing the definitions of data structures. And to do that, we had some functions that were here next to the data structures themselves. So for instance, there would be a function here that would tell the system how to initialize the array data structure itself, not how to initialize an array, but the definition of what an array even is in our system. We no longer have that because we decided that it wasn't really worth having that as having the data structure definition as a data structure in and of itself. So we got rid of that, but the trick is going to be the same. We are going to have a function here that will be something like, I think, yeah, I'll have something like this, test, and then I will do this over here. So this function is going to return a Boolean. And I'm thinking if I should do this here or not, but I think I will do the string manipulation here as well. I'll do something like this. Well, something like that, actually. So there is a little bit of repetition here, but it's not the end of the world. I'll probably do just something like this. And I think it stands to reason that I namespace this, because it's no longer in an effect, it's now part of the library. So I think it makes sense to have it like this. In fact, since everything is committed, I can start playing around with this, and if we decide to revert, it's a simple matter of git reversing the thing. So I'll just rename everything here with the underscore dot, and then we'll move things over. So, okay, and maybe I will get rid of all of this and put it on a temporary buffer, cleaning up the tests effect. So in the init block, we don't really have to do any work. In the serialize block, I think it's nice to have this because it's sort of like boilerplate that should exist in every effect we ever write. So then we have the gfx block, or maybe in the init block we'll call tests. How about that? And then, yeah, I think it will work something like this. Then below everything, but above the design system, because I don't think it makes sense to write tests for the design system, so I will have that closer to where we will be interested in reading it in the file. So let me find right before the design system, I'll have something for tests, and it will be a function called tests. So that's this function that it will be called here. And what it does is simply call all the registered tests. Oh, it also has to initialize the tests variable, so it has to do this. Not in love with this design, but we'll see if it works. So you have to, for each test that you write, you have to register it here. Okay, so far so good. Let's see. I'm going to drop the test effects, the tests effect, and it passes. So this new architecture has potential. Yeah, I only want to run the tests once, so it makes sense to have that in the init block. One thing that I'm maybe not in love with is this idea that it will have this global variable that it changes, but the tests are effectively a singleton. You're supposed to run them only once, so communicating via global variables may be okay. Oh, and the function name and the variable name are the same, but it seems to work, so that's good. I didn't know that you could do something like this. I could have something that... Yeah, I think I could have something that would like create a string here and then pass it for every test and then return it. That would get rid of the global variable. which I think is a nice move. So let's try that. But I do want to commit what we have because I like it. If I'm not in love with it, but I like it better than what we had before. So if this doesn't fly, then we can always revert. So the way that this would read is like this. And then over here, I would have a local variable. Oh, no, in this context, it's an argument. It's not a local variable. And over here, it is a local variable. Let's see if this is passing. It's not. Oh, I think I know why. We are not returning this. Should be returning that. Second try. Still not passing. Or not showing anything. Why would that be? Let's see if we are leaking any variables. No. Then what's this? It evaluates to a string number. That's okay. So maybe it doesn't like this concept of having a local string. I don't think that I can do this, however. I think it's going to complain about that. Yeah, strings can only be instants or globals. So that's not going to work. And if we check tests, it says that it's empty. So maybe the issue is that here in the milliseconds to samples test, it's changing this, but it's an argument, so it's not changing the outer one. It's only changing the inner one. Well, then what if I return tests? And then when calling this, or actually I can just plus equals this and I don't need to receive that. I just have to make sure that this is going to return the right string. And that's easy to do. Can I do it like this? I don't think I can. Let's see. Yeah, but what I can do is consult the JSFX documentation and there is this string catch. Yes, string catch. The scope of these temporary instances is very limited and unpredictable. Isn't that the kind of thing you want to read? Literal strings are immutable. I don't necessarily want to mutate the strings. But what I do want is to put them together. I want to concatenate strings, so I think I will need a string object to begin with. Yeah, this is not good. Okay, I'm gonna revert this and we are gonna try something else. So what if the test returns simply whether it passes or not? Because that's really what you want to see when you're reading the code. That's what you want, that's what you care about. Then over there, here I will concatenate stuff. And naturally at the end of this, I was going to say that I want to return it, but no, in this case, we don't return the thing, we communicate using global variables. Yeah, let's see if this works. It should. It does. Yeah, the main issue that we have is the communication between functions, or between the global scope and locally scoped variables. So that's the main issue. So this is fine. And then let's see what this looks like when we are implementing a new function. It actually looks great. We have the implementation and we have the test right next to it, and all we gotta do is return a Boolean. That feels great from a reader's perspective, at least it does to me. Then over here, this also feels very, very nice. I'm registering a test in a way that makes a lot of sense. There's a little bit of repetition, but it's fine. It's mostly going to be a giant list of a manifest of all the tests that I want to run. And then it's easy, if I have some broken tests, it's easy to just come here and comment out the right line. So good stuff here. And then from the perspective of using the tests, which is not a big deal, this is probably going to be the only effect that runs these tests. So I run them here and I print them here, and there is this nice thing where the string name happens to be the same as the function name, which appears to work. So I'm happy. Good stuff. So I think that this is what we are going to do. Now, all we have left is to port all the tests. So we'll do that now. Why not? I do have a song for this. Do I have it here? Yes. Enjoy. Right now I'm doing something boring. You're gonna have to wait. I'm probably renaming some variables or something like that. But the show must go on. So I wrote this song to keep you entertained. I hope you're entertained. Thanks for standing by. I'm sure it won't take long. And then we'll return to coding or whatever we're doing. Meanwhile, the show must go on. So I wrote this song to keep you entertained. I hope you're entertained. Usually I try to read from the chat when I'm doing something like this. But now, for whatever reason, I think I need to concentrate. Please do me a favor and talk among yourselves. As soon as this is over, I'll catch up with what you say. Meanwhile, the show must go on. So I wrote this song to keep you entertained. Meanwhile, the show must go on. So I wrote this song to keep you entertained. I hope you're entertained. Oh, the song is over. Yeah, as you can see, when I'm doing this sort of repetitive work, I try to automate some stuff, like I removed all the underscore test situation from here, so I only have literally the tests that I need to copy over. I'm trying to use multiple cursors to make some things faster. This is hyperbolic functions. And I think I have a trick to play at the end to register all the test functions at once. We'll see when we get there. I'll call this the inverse hyperbolic functions. Do you want to hear the song again? Right now I'm doing something boring. You're gonna have to wait. I'm probably renaming some variables or something like that. But the show must go on. So I wrote this song to keep you entertained. I hope you're entertained. Thanks for standing by. I'm sure it won't take long, and then we'll return to coding or whatever we're doing. Meanwhile the show must go on, so I wrote this song to keep you entertained. I hope you're entertained. Usually I try to read from the chat when I'm doing something like this, but now for whatever reason I think I need to concentrate. Please do me a favor and talk among yourselves. As soon as this is over, I'll catch up with what you say. Meanwhile the show must go on, so I wrote this song to keep you entertained. Meanwhile the show must go on, so I wrote this song to keep you entertained. I hope you're entertained. Oh, look at that timing. Right as the song ended the second time, I finished the tests, or I finished the busy work of translating this. But still we have to review stuff. Right, so the trick that I mentioned that will maybe speed things up is I can use option F5, what an awkward keyboard shortcut, to check all the places that I changed in the file. And I'm now going to check that they all define functions ending with .test, because what I have next is anchored on tests, or having .test at the end. Let me go over again. Okay, test, 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 test. We have so many tests. They're all good. Great. So now we can just look for .test, and what I'm going to check next is if they are all returning Boolean values as they should. So I can just look for .test and go over all of them. I'm also going to check if they end with a semicolon for stylistic reasons. I want to have semicolons at the end as the last expression in every function that I define. Okay, looks good. Oh, something is awkward about this one. It seems like it's missing. Oh, okay. Yeah, because I need to change the element size to test this. So I'll create a local variable here. And I will return it. And here I also need a local variable. Oh, and I'm doing memory allocation in some of the tests, which makes sense, justifies me putting stuff in the init block, because I don't want to allocate memory outside the init block. So everything is falling into place like a jigsaw puzzle. Isn't that rewarding? Now I'm going to go over everything again to check that the test corresponds to the function that is right above. Okay, looking good. So next, what I need to do is to register all the test functions. And to do that, I am going to find all the places where I have .test at the end as the anchor, and I'm going to Command-Shift-L. And then I'm going to Command-Shift left arrow to go to the beginning of the line, and Option-Shift right arrow. This way I grabbed just the name of the function regardless of how long that function is. And I'm going to go to a new buffer and paste. So these are all the functions that we need to register. And it seems like this last one is just it's junk. These are all the functions that we want to test, that we want to register for the tests. Now let's find where we register the function. So this is the line that I want to have in all these locations. So I will do something that looks like this. And Visual Studio Code thinks that this is Ruby code. So let me change this to JS effects or to EL. And then the syntax highlighting is working now. So this registers all the functions, all the test functions. And as a smoke test, as a sanity check kind of thing, let's look for the tests. How do we do that? I guess I just count 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. There are 19 tests. And how many lines are there here? 19. Awesome. I think it thinks that this is Ruby code because of this symbol here. That is the symbol for comments in Ruby. So no, that would not be the case. No idea, go figure. Right, so it seems like we registered all the tests and all the tests should be passing. So as we load the effect here, we should see the same result as before. And we do. Awesome. All the tests are still passing. And now we have a much more principled way of writing tests. I very much like this refactoring, though I admit it took most of the stream. So I was expecting to get to the waveform display and I may not get to that, but that's fine. Let's review what we changed once more. And then let's see if we tested everything we implemented, because I think I skipped over some. So this is tested, that's tested, this is tested, that's tested, this is tested, that's tested, that's tested. And the tests are much longer than the function definition themselves, but that's just how tests usually go. Count trailing zeros, follower, map, wrap, circular counter is tested, distance Euclidean is tested. This is not tested. I think we should. I think we should test this. Why not? So we could test the specific values here, but I think it makes more sense to just test that the values are different, because that's the intent. The intent is that when I call enumeration new, I will get a new value. So it's kind of a silly test, but it's worth having it. And then let's register it right below, well, right above memory allocation. So let's look for memory and then copy this, replace there. And then drop it in the track again and look for, what did we test? Enumeration. It's passing. Memory is tested, array is tested, circular buffer is tested, and then all the tests, and then the design system. Amazing stuff. It's looking great. Look at the amount of code we wrote together in this stream. It's crazy. Oh, and the constants need to be here because of this. All right. So, where are we? I think we did everything we wanted to do in terms of refactoring. And then the cool thing is that I will not have to touch this file again while developing the library. Well, while developing auxiliary mathematical functions for the library and the sorts of things that you can unit test. That's good. And let's see if I forgot something, if there is any variable that is leaking. Yes, we have size and position. So now we'll look for size. Over here, that's okay. So it's probably going to be at the end. Yep, I think I found it. It's here. Local size. And then we also have position, which is also here. Now, these two may not be the only instances, so we have to double check by removing the effect from the track and adding it again. And now we are not leaking anything. Amazing work. Very happy with this. Look at how many variables we have. It's amazing. We wrote everything with our bare hands. Right, so everything that we have implemented is tested. Our unit tests are next to the functions that they test. It's just amazing, lovely. I love it. How is our circular buffer looking? Yeah, I was going back and forth in my mind if the circular buffer should support multiple channels or not. I think so. The reason why I want to implement multiple channels is they are useful. Usually when you have a circular buffer, you will want to have one per channel or even two per channel, that sort of thing. So that's useful. That's why I want to have the circular buffer be multi-channel. But as we start the implementation of the waveforms, or revisit the implementation of the waveforms, because we have implemented them before, we will need a notion of a maximum value and a minimum value. So then we have two circular buffers per channel. And this whole channel abstraction starts to break down. So I think I want to change the functionality of the circular buffer ever so slightly and have just single channel supported. I think it will make more sense overall, and it will be a bit more costly in terms of memory accesses, and you will have to circle the indices of the buffer. Yeah, well, I guess it is what it is for now. We'll see. We'll see. And I wonder if I should put the waveforms next to the circular buffer or to the waveforms. I think it makes more sense to put them, or to the design system. I think it makes more sense to put them below because it has to do more with like graphical user interface. It's not so much a data structure. For instance, I will not test it using this. So the right place for this to be, I guess, is below the design system. But above the constants. Yeah. So I'll have something like components, GFX components. It is what it is. And I could refer to the code that I already implemented for the waveform display, but I think I will make some different decisions this time around, so I will not revisit that code. All the important information that I have is over here and over there as well, if you are watching this carefully. So now it's the time to decide whether I want to have the waveforms be multi-channel as well, because multi-channel waveforms are the natural thing. But it will get annoying. This whole notion of multi-channel is going to percolate over the code base. And if I have it in the circular buffers, I might as well have it in the waveforms, and then I might as well have it in the filters, because you probably want to have filters like low pass, high pass, that kind of thing. You probably want to have them multi-channel as well. So I don't want to establish that pattern. And I think I'm going to revert my decision on the circular buffers, my decision from yesterday. So this is the circular counter, that's not it. And I will remove this comment because really it's documented already in the use of the function that is right below. So yeah. Yeah, circular buffer. So it will not have the notion of channels. It will only have the notion of size and the current position in that size. So everything that has to do with channels can go away. It will only have a size. And then I don't need to allocate 3 pieces besides the size. Just 2 pieces. The size itself, the position, and then I allocate the chunk of memory. Then the size is over here, that's gone, and the position starts at 0. Okay, that makes sense. Then how do I create... Oh, this was an overloaded version for when you don't want to provide the number of channels. So I can get rid of that. This is also an overloaded version for when you don't want to provide the number of channels, and this is the same story. So I can get rid of all of those. Then this thing that has to do with channels, I can get rid of. So how do I set a value? Oh, I don't need to multiply by the size at all. I can do just that. So I don't need to get a hold of the size in this case. See how everything is getting simpler? That's a good sign. And then this position, I can just do that. No, I think I'd rather have the local variable. It's nicer, and JSFX is probably gonna inline this anyway, so I think I prefer it like this. And then this advancing thing, usually before we had this notion of multi-channel. So you would set to the multiple channels and then advance. But now we probably want to have an auxiliary function that is probably going to be even more useful. I still want to keep this around though. I could inline the setting here, but I think it's worthwhile having this set situation, because there will be some situations in the circular buffer where you want to set a value on top of something that is already there without advancing the pointer. Not really. Yeah, not really. So let's inline these two. Does this look right? Well, we are getting the circular buffer and we are getting its position and we are setting the value there, and then we are advancing the pointer. I think I want to do it the other way around, where I advance the pointer first and then... Yeah, I'm going to advance the pointer first and then write, so that if you push and then you look at position 0, your value will be there. So in that case, it makes more sense to initialize this at -1. doesn't make a big difference, but I do want the first value to sit in position 0 in the buffer. It just makes more sense to me logically. Okay, yeah. I like this. Then, so I will be able to push values and to get values. And then I don't need the channel information over here. Yeah, I really like the ways that this reads. This first part is the same in both implementations of both functions. And then this is me doing some work with the position in both situations. And then accessing the buffer in that position to either set or get. This makes a lot of sense. And when pushing a value into the circular buffer, it could be nice to return that value. Yeah, the order in which I do these two operations doesn't matter. And if I do it in this order, then I'm returning that value, which may be useful because usually when you do something like this, the result of this expression is 2. So I like that, but really you shouldn't be relying on the result of this expression, but it also reads better because this is at position -1 and this is at position like greater than or equal to 0. So it also makes sense logically when you're reading. Great. So now let's just rewrite the test for this. We'll create a new circular buffer that will have a size of 3 but not multiple channels. So anywhere where you see this, get rid of that. And anywhere you see this, get rid of that too. And when I say set, I mean push. And when I say advance, I mean that. And if I play my cards right, I think that this test is already passing. Let's test. Circular buffer test is passing. Great. So now we changed the circular buffer from multi-channel to single channel. And check this out. The whole implementation with the tests and everything fits in one page. That's amazing. Very happy with the results of today's coding. Simplifying, lots of concepts. It usually goes like this. I make things complicated. I see the truth, make things simple again. So now let's do this GFX component. I think that the first thing I want to try here is to rectify the waveform, which is something that the previous version was not doing. So yeah, it will be different. Waveform, new. And for the waveform, you need to give me a bunch of things. You need to give me the number of slots that you want the waveform to have. And I think I was calling this the number of slices. Yeah, the waveform is going to be composed of like slices. And then you need to give me the duration in samples. Yeah, I was thinking of using this as sort of a Hungarian notation to say that this is in samples, but I'll just leave duration there and establish the convention that usually the duration is given in terms of samples. And we do have auxiliary functions to convert from seconds to samples if you want. So with this, the number of slices and the duration that I want for the waveform, yeah, I have everything I need. So let's create a waveform, which will be, it will need to be 2 circular buffers, one for the maximum, one for the minimum. Oh, but I'm gonna rectify the waveform. So yeah, let's play around with this rectified version of the waveforms. So the waveform is just a circular buffer. And it needs to store slices, not slides, slices. And that's all there is to it. No, it's not all there is to it. I will need the number of slices will know its own. Yeah, the slice is going to be a circular buffer, so it knows its own size. It's only the duration that I need to store. Yeah, so I do need to store the duration in samples. I'll do that in position -1. No, I think that I will have this as an array. I don't need this data structure to be super optimized. And I don't think I'm going to index into the waveform directly. Well, I can index into that. And the for the rectified version, that makes sense. So let's make the rectified version super optimal. Why not? And samples in slice will be in position -2. Great. So this is going to be oh no, I cannot do that because the circular buffer itself doesn't allow for this ultra optimized thing of where I use negative indices. Or does that work? Yeah, no. Unless I store the size, no. Let's make it just a good old array. So a waveform is not a circular buffer. I'll call this the samples. So this is going to be an array of 3 positions, 0, 1, and 2. In position 0, the duration I just take from there. The samples in the slice, currently there are 0 samples in the slice. And samples is going to be a circular buffer of that size. And the waveform is what I return. Looking good. Then I want a function to push a sample into the waveform. I will need to grab these guys and I need to push. Oh no, I don't need to push into the circular buffer. I need to have some notion of the current slice. I think I will do it like this. So this is like configuration, and these are dynamic values that are going to change. So now I need 4 slots, and I need to do something to initialize a slice. And I'm going to initialize to minus infinity, because this is rectified, so it's in dB, and the lowest value is minus infinity. Infinity is a constant that we have over here. It's just a big number. And then I will need to check if I am approaching this number of samples in slice is equal to the duration. No, I need to divide the duration by the number of samples, or the size of the samples here, size of slices. Oh, that's weirdly named. This should be called slices. That makes more sense. I'm calling it size. And I'm calling array size, and everywhere I'm calling it size. Should I be calling it length a la JavaScript? Should I call it size? I think I'm going to rename this to length. And then I need to review my changes, and I'm gonna wrap this up. I'm not gonna finish the waveform today, but at least it should be passing the tests, and the half-finished work should be syntactically correct. Let's review this change of length. Oh, this is not length. This really is size. So starting from here, I want to revert this. I also want to revert that. Okay. Okay, so far so good. I think that this is fine. Let's run the tests one last time, and then we'll call it a week. Oh no. Line 1, 2, 2, 4. Oh, okay. I know what it is. Should be saying waveform here. And then the tests are still passing and everything. Yes. So we are going to leave this as is for now. I think we made some great progress with the testing thing and with this notion here of circular buffers. Very simple code, straightforward, I love it. And we even got started with the waveform rectified, so it's not too bad. Enjoy your weekend. I see you back on Monday, and I think I will be streaming with Aria over at iDidYouKidU Sound. We will be talking about some Lua scripting, supposedly. We'll see. And then on Tuesday, there is the second meeting of our C++ Juice DSP group. So look forward to that on Tuesday. And then on Wednesday, we will be talking about synthesizers over here. So I'm going to get back to this on Thursday. Yikes, we have lots of segments on this stream. So yeah, it is what it is. Next Thursday, we'll revisit waveforms. Enjoy your weekend. Thanks for being here. Bye.